Let's continue with examples. Find the volume of the solid obtained by rotating about the x equals -2 and the region bounded by y equals 6 and y equals x plus 5 over x. Before we calculate the volume, we need to visualize the circumstance. This is just a vertical line. This is a horizontal line. This is a little bit confusing, but you learned it from college algebra. When the equation looks like this, there is a slant asymptote. Slant asymptote is determined by the added component, that is y equals x. And what makes the denominator 0 becomes a vertical asymptote. So vertical asymptote is x equals 0 because denominator must be 0. Let's graph it. We think about y equals x, which is a asymptote, slant asymptote. And we have y equals 6. Let's say this is y equals 6. So this point is 6. The axis of rotation is x equals -2. So this is x equals -2. The vertical asymptote for this rational function is x equals 0. So that is y-axis. And that has slant asymptote here. So that should be something like this. What we want to do is find the volume of the solid obtained by rotating about x equals -2. So we rotate around here. And we consider the region bounded by y equals 6 and y equals x plus 5 over x. So we think about these two graphs. We rotate this region and we think about the volume. Yesterday, we were talking about cylindrical shell method. When we think about the cylindrical shell method, we think about the stick, which is parallel to the rotational axis. For disk method, you have to draw the stick, which is perpendicular to the rotational axis. But we are thinking about the cylindrical shell method. So we will draw the stick, which is parallel to the rotational axis. So this one is delta x. And the cylindrical shell is formed by rotating like this. So we considered the circumference, the radius of the circle is determined by the distance between this rotation, axis of rotation, and this stick. Let's say this value is just the x, any point x. Then the distance between this vertical line and this vertical line will be x minus 2, which means x plus 2. That becomes r, radius of the cylinder. To fit into the formula, we have to calculate the height. Height is the difference between the larger graph and the smaller graph. Obviously, the larger graph is y equals 6, and smaller graph is this rational functions graph. So height of the cylindrical shell is 6 minus x plus 5 over x, which is 6 minus x minus 5 over x. That is height. We think about just this thickness is delta x. And so when you formulate something like dx, right? We have to think about the x range of this object. That means we have to figure out this point and this point, x value at the intersection point of two graphs. Let's figure out the intersection point. At the intersection point, y values must be the same. So we have an equation, x plus 5 over x equals y value 6. Let's multiply by x on both sides. Then By distributing x times x will make x squared plus x times 5 over x will make 5 equals 6x. We subtract 6x on both sides, then we get x squared minus 6x plus 5 equals 0. So we factor that into x minus 1 times x minus 5 equals 0 because 5 is minus 1 times minus 5. And when we add them up, we get the number in front of x. From here, we got the x-intercepts, or the x coordinate at the intersection point. That is x equals 1 or 5. From the equation, x minus 1 equals 0 or x minus 5 equals 0. Now we are well set to figure out the volume. Volume is from x range 1 to 5, 2 pi times r is x plus 2 times height was 6 minus x minus 5 over x dx. Let's pull this out. Then we have 2 pi outside of the integration, 1 to 5. And then we will use FOIL, just a distribution. The x is multiplied, so 6 times x minus x squared, x times 5 over x is just a 5, so minus 5. Plus, we just multiply 2 for each term. So that is 12 minus 2x minus 10 over x dx. Let's simplify a little bit. Then that is 2 pi integration 1 to 5. The largest degree term is minus x squared. And then 6x minus 2x can be combined to make 4x. And 12 minus 5 will be 7 minus 10 over x dx. So 2 pi. And we do term by term integration. Then that is minus x cubed over 3 plus 4 times x squared over 2 plus 7x minus 10 natural log of absolute value of x. Integration was from 1 to 5. We will plug in the number. The larger number was 5, so we will do that first. Then 2 times 5 squared minus 5 cubed over 3 plus 7 times 5 minus 10 natural log of 5 minus the smaller number was 1. So That is 2 minus 1 over 3 plus 7 minus 10 natural log of 1. Here, natural log of 1 is 0. So this term will vanish. But other part is just the arithmetic algebraic calculation. So I don't like to go through all the details. And then we have to finally get 2 pi times 104 over 3 minus 10 natural log of 5. So you have to calculate this part with this part, and this cannot be combined. So that ended up here with the same one. And the other one is just a combination of integer and fraction calculation. Any question? We are finishing this section. Let's move on to chapter 7. Chapter 7 is techniques of integration. Seven point one is integration by parts. Integration by parts is the reverse operation of the product rule in derivative. Let's recall the product rule. Product rule is applied to the product function. Let's consider the derivative of f times g. Then product rule implies that the first function's derivative times the second function plus first function times the second function's derivative. To derive the integration by parts, we integrate both sides. So we have integration of f of x times g of x prime dx equals integration f prime of x times g of x plus f of x times g prime of x dx. Here, g prime. From here, what we get will be by fundamental theorem of calculus, which essentially says that integration and differentiation are reversing operation. So when we reverse the operation, we get the function itself, which is f of x times g of x. And then we can do term by term integration. integration f prime of x times g of x dx plus integration f of x times g prime of x dx. And then what we want to do is we want to move this one to the left. Then we have to subtract the same thing on both sides. Then on the right side, these two will cancel each other. And then we just switch it the left and right side. Then left side, we have f integration of f times g prime. Integration f of x times g prime of x dx equals f of x times g of x minus integration f prime of x g of x dx. This is a so-called the integration by parts. If you look at the formula, then it looks complicated. So I will describe the simpler version with the simpler notation. To do that, let u equals f of x and v equals g of x. Then we can say that du equals f prime of x dx and dv equals g prime of x dx. The integration by parts, when the setting goes like this, it starts with u dv initially, this part, and then this one combines u and v, and then minus integration f prime times g dx. So when we reformulate, that is u dv equals uv minus integration v du, this diagonal one. You have to remember the clear process and how the integration is formulated when we use the integration by parts. If you do the example, then it'll be a lot easier. The next one is evaluate. Integration 4x squared natural log of x dx. What I told you was we start with u and dv. So that means when you look at the formula, we will use du and also integration of dv, this part. So one of the chosen function must be differentiated and the other one must be integrated. So in general, when we decide which one should be u and which one should be dv, we just look at the functions, two functions, and then usually when we choose u function, when we differentiate, it becomes simpler. And in this case, the other function, when we integrate, it is not, it doesn't make the things more complicated. But in this case, what you would notice is you don't really know what the natural log of x instantly, but you know that when you differentiate, it becomes 1 over x, right? We can differentiate it easily, but integration is harder. So what you can attempt to do is you will put u is natural log of x in this case. And the dv will be automatically become 4x squared dx. And then we have to calculate du and v. Du equals 1 over x dx. And v equals what? If we integrate 4x squared dx, then that is 4 times x cubed over 3. So that is 4x cubed over 3. So v becomes 4/3 x cubed from here. So this is integrate. So again, this diagonal to the right is the original function. And then you connect like this, and this slant toward the left is minus integration. And this horizontal one in the formula is multiplication. Any question? And then let's follow through the formula. The given integration is integration 4x squared natural log of x dx. So when we follow the formula, that is natural log of x times 4/3 x cubed minus integration 4/3 x cubed times 1 over x dx. Then the first one can be rewritten in a nicer form, 4/3 x cubed natural log of x minus, what is this? This is x squared. So we have 4/3 integration x squared dx. And then that is 4/3 x cubed natural log of x minus 4/3 x cubed over 3 plus c. When we just simplify, it becomes 4/3 x cubed natural log of x times minus 4x cubed over 9 plus c. Okay, let's do another problem. Evaluate integration x squared plus 8x times cosine of x dx. I said you have to determine what must be u and what must be dv first. One function will be differentiated and the other one will be integrated. In this case, when we differentiate x squared plus 8x, the degree becomes lower, and so the algebraic expression will become simpler. So we will put u equals x squared plus 8x, and when we get cosine x dx as dv, when we integrate that, that is just a similar complication, because it'll be just a sine function. So du differentiate, so 2x plus 8, and for this part, we integrate v equals sine x, right? So this time integrate this one, differentiate. And this diagonal was the original one, and go this way. This is minus integration. Let's rewrite the given integration according to the formula. Then integration x squared plus 8x cosine x dx becomes the multiplication of 2. So sine of x times x squared plus 8x minus integration, this one times this one, which is 2x plus 8 times sine of x dx. Different from the previous problem, in this problem, we have to apply the integration by parts one more time to conclude the problem. But pattern of the function we are obtaining is similar. So we will use the similar strategy. So u equals 2x plus 8, and we will put dv equals sine x dx. And then we differentiate u, then we get 2. And if we differentiate the integrate dv, then we get minus cosine of x. So that means sine of x times x squared plus 8x minus this one times this one will make 2x plus 8 times minus cosine x minus integration 2 times minus cosine x dx. So let's do distribution. The first term, I copy the first term, sine x times x squared plus 8x. And then we multiply -1 to the first one and the second one, right? So if we multiply -1 to the first group, then this minus and this minus will make plus. So we will have plus 2x plus 8 times cosine x. For the second one, this minus and this minus in front of integration will make plus, right? So we have plus integration 2 times minus cosine x dx. So that becomes sine of x times x squared plus 8x plus cosine of x times 2x plus 8 minus 2 times sine of x plus c. Because integration of cosine is just sine. So I put this minus in front of that and then integrated cosine to get sine. Let's do one more problem for today. Evaluate integration 14 natural log of cubed root of x dx. The integration 14 natural log of cubed root of x dx can be written as 14 times, what is that? Natural log of x to the 1/3 power dx. In this case, this is not a multiplication, this is a power. 1/3 is power, not the multiplication. So in this case, we see only one function, which is a logarithmic function, but we still can do integration by parts to integrate this natural log of x to the 1/3 power. As we have been doing, if we have natural log, then that'll be u. So we have natural log of x to the 1/3 power, which can be written as 1/3 natural log of x. And dv, in this case, we just perceive this one as 1 times natural log. So 1 can be integrated. So 1 dx, and then v equals just x, right? And then du equals 1/3 times 1 over x dx. After that, we will combine all the things with the formula. So we multiply these two, then we have 1/3 natural log of x times x minus integration x times 1/3 times 1 over x dx. So that is 14 times x over 3 natural log of x minus these two will cancel each other. So integration 1/3 dx. So we can conclude that that is 14 times x over 3 natural log of x minus 1/3 x plus c. You can do distribution to conclude the problem, but this can be the final form of the answer. Any question from what I did today? There are many formulas. As I said, you have to make formula sheets so that all the formulas are very clear. And when you study, you have to remember the strategy together, and also pattern and strategy, so that you're not confused when you take the exam. The exam time will be only 50 minutes. So if you're just try to do your own reasoning and wonder for a while, then you will suffer from lack of time. And so everything must be pretty much remembered. And the formula sheet is not allowed for the exam. For quizzes, which will start from the next Monday, that is open book quiz. You can discuss the problem together and you can bring your note, but I will not allow you to use electronic device. But for the exam, the department standard is having you remember all the formulas and strategies related to this course, because this is the preparation for Calculus 3. You have to remember things clearly. When would we know if we have to do the process of integration twice? That is just a, usually that happens when you have like a sine or cosine function combined with the polynomial, which is more than degree 1. And you just have to make progress, and then you will see whether you can conclude the problem by integration, one more integration. Because the integration cannot be concluded, then you have to figure out how to evaluate that integration. That when you try to figure that out, you may realize that you have to apply the integration by parts more than once. I'm not sure. It is a Monday. Is that February 7th? Is the exam 1 February 7th? We have to look at the syllabus. But when exam approaches, you will get an announcement because I have to, I want to remind that to you. Will the exam be open note or only the quizzes be open note? Only the quizzes will be open note. The exam cannot be open note, especially at the end of the semester. All the calculus students will take the same exam. That'll be uniform exam, and so our class students should be well prepared. And that'll be Saturday during the final exam period. For the cylindrical volume problems and washers problem, will we be given the graphs of the functions? That's a good question, actually. I would say that if the graph is a little bit more technical, then it may be given, but it's more likely not very technical graphs, but you have to draw the graph and then figure out the intersection points and so on. So expect that the whatsoever you get in the problem, I think Doge must be something to do with the graph of the functions which you learned in college algebra. So you should be able to figure out the graphical shape. But what I want to emphasize about the cylindrical shell method and washers method, again, that washers method, you draw the perpendicular stick, and cylindrical shell method, you will draw the sticks which are parallel to the axis of rotation. So remember the strategy clearly. And when we think about the washers method, we think about the disk area of the disk. And so 2 pi r squared is involved. But when we think about the cylindrical shell method, we think about the circumference of the circle. So you will think about 2 pi r. And then just visualize it and think about how to proceed and how to analyze the graph. Do you have any other question? If you don't have any other question, then you can leave. But if you have question, then you can remain and continue to ask me question. You're welcome. All right, have a good day. I'm ending the class. See you tomorrow.